Hello, my Algebra 2 students. So today's notes are on naming and manipulating features of a linear function. So we're going to use our knowledge of what a linear equation means to answer some questions about it. And I'm going to do this without graphing. If you feel like you need to sketch the graph, you can. I'm not going to. So if we look at our first equation, y equals negative 3 halves x minus 5, we're going to answer all of these questions about it. This is stuff that we have been going over, so hopefully we kind of remember how this works. So for the y-intercept is part of the equation, which is at negative 5, remember, because that's the b from y equals mx plus b. So that means that this line would cross the y-axis at 0, negative 5. The slope is also part of our equation. That is the m of y equals mx plus b. So this equation has a slope of negative 3 over 2. Now the x-intercept isn't part of the equation, but I do have enough information that I can find it. I know at the x-intercept that y has to equal 0. So for my equation, I'm going to plug in y equals 0, and I'm going to solve for x. So 0 equals negative 3 halves x minus 5. I'm going to add 5 to both sides. We're going to get 5 equals negative 3 halves x. If we multiply both sides by the reciprocal, which is negative 2/3, we are going to get that x equals negative 10 over 3. That means that our x-intercept is negative 10 over 3, 0, also known as negative 3 1/3, 0. Our domain is any x value that we can plug in there. There are no restrictions. You can take any number and multiply it by negative 3 halves and then subtract 5. So the domain would be all real numbers, or you could put like negative infinity to positive infinity. Either of those would be an acceptable answer. For the range, if you were to think of the graph, it is a line. It goes as high up as negative infinity and as far down as negative infinity, which means you can get any answer for y. So it also is all real numbers or negative infinity to positive infinity. Now the end behaviors. If I'm thinking about this graph, I know it's going to go downhill. So as x goes to positive infinity, I know that y goes to negative infinity. That means it's going downhill, so down to the right. Now if I were to go the other way, when x goes to negative infinity, so when it's going to the left, it's going the opposite direction and it is going to positive infinity. Because if you think about what this graph looks like, it is going somehow downhill. So the right side is going to positive infinity on the x, negative infinity on the y, and the upper left is going negative infinity for x, positive infinity for y. So we have two end behaviors. Now the increasing intervals, it's not increasing anywhere, so I'm just going to put none. Now the decreasing interval, since I know that the slope is negative, this line is going downhill, so it is a decreasing interval everywhere. And remember that we label those based on the x-axis, so it is decreasing from negative infinity to positive infinity. Now we're going to change one slight thing on our equation. We're going to now make it a positive 3 halves slope. So y equals 3 halves x minus 5. So again, our y-intercept is at negative 5 because that's the b version from our equation. The slope this time is going to be 3 halves. I'm going to make our slope positive this time. To find the x-intercept, I know that y equals 0 on all x-intercepts. So I'm going to plug in x equals 0, and y equals 0, and I'm going to solve for x. So I'm going to add 5 to both sides. I'm going to get 5 equals 3 halves x. Looks very similar to what I did last time. I'm going to multiply by the reciprocal, and again I'm going to get x equals 10/3, but this time it's a positive 10/3 instead of a negative 10/3 like it was last time. So it crosses the x-axis at 10/3, 0, also known as 3 1/3, 0. The domain, it's still a line where you can plug in anything. I can multiply any value of x by 3/2 and then subtract 5. So that would be our all real numbers, also known as negative infinity to positive infinity. And our range, it goes as far down as negative infinity, as far up as infinity. I can get any answer in there. It is also all real numbers, also known as negative infinity to positive infinity. Okay, end behaviors. Now this is different from the last one, because if this line is going uphill, and this is kind of what I'm seeing in my brain whenever I'm thinking, I know it's going to go uphill somehow. So if it's going uphill, that means as x goes to positive infinity, it's going uphill. So that means that y is also going to positive infinity. And if we go backwards, where if x is going to negative infinity, I now know that y is going to negative infinity. So those are those end behaviors. The increasing intervals, it actually is an increasing line. Since our slope is a positive, it's increasing everywhere. So the interval is negative infinity to infinity. The decreasing interval is nowhere. It's not going downhill at all. It's going completely uphill because it's a positive slope. Okay, so you will be practicing that in class on Monday. There's also one more thing I want to talk about is translating a line. So think about geometry and the word translating. So if I were to take a shape and I were to translate it, it means I don't change its orientation, I don't reflect it, I just move it around, move it up, move it down, move it left, move it right. That's all it does, is it moves in some direction like that. So if we were to first graph the line y equals 2x, starts at 0, up 2 over 1, up 2 over 1, and my line would look something like this. So this is a graph of the line y equals 2x. Okay? Now it asks us to translate y equals 2x up 3 units. So if I were to take one of those points and translate it up 3 units, it means I'm going to count up 1, 2, 3. I'm going to put a dot right there. I'm going to do that with a couple of them. 1, 2, 3, 1, 2, 3. And what I end up with is a line right here. So my line is now up here. So if I were to look at that equation and write the equation for that graph, my slope is still the same. It's still 2x. However, it's up at positive 3. So the equation of that line is now y equals 2x plus 3. Now, if I were to take that same pink line, the y equals 2x, and translate it to the right 4 units, I'm going to take every dot and I'm going to go to the right 4 units. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and I'm going to draw the line for it. And it also, need to make it a little bit longer. I think that's going to be at, there we go. 1, 2, 3, 4, 5, 6, 7, 8. I think this is at negative 8. So I'm going to translate it down. It's going to translate to the right. I moved everything to the right. And the new equation, it still has the slope of 2x, but it now crosses the y-axis down at negative 8. So we're going to use that a little bit more, thinking about translating. We're going to do some problems in class, and make sure you write all of your notes. Last thing, the first 5 people who email me that actually watch this video, I will give you bonus points.